we observe that we have same base, and then we also observe that we added the exponents. Okay, so in general, we can say that if I have a monomial raised to an exponent n, and I have the same monomial, okay, sorry, I have a monomial with the same base with the first one, and then it is raised to m. The key here is that we have the same base. So we can just copy the base and then add the exponents. Okay. Note that if I have, let's say, a squared times b4, for example, then we cannot add the exponents. Okay. So just leave it as is. This one will just be equal to a squared b4. We cannot simplify this anymore. Okay. We can only add exponents if we have the same base. All right, that's rule number 1, product of powers. So base stay the same. And then multiply the exponents. Okay, so in general, if I have let's say s raised to n, and then the entire thing is raised to m, we just have to copy the base and then multiply the two exponents, n times n. Okay, so that will be our general rule here. It's power of power. I have exponent raised to another exponent. So we just have to multiply those two exponents. Next, power of a product. Any conjecture for this rule? Distribute the exponent. Okay, what else can we observe? So general rule here, if I have expressions inside the parentheses and I have an exponent, we can distribute our exponent to the exponents of the expression inside the radical sign. Inside the parentheses. So I suggest that you write the exponents of a, b, and c. If you can see an exponent, it means that exponent is equal to 1. And then you distribute your exponent n to each of these exponents. So you will have a raised to n, b raised to n, then c raised to n. Okay? Notes. Don't ever do this one, okay? If we have, let's say, 2 a, for example, raised to 3, okay, do not ever do this one. Don't say that it's 2 times 3 and then a. Okay, this is wrong, okay? I'm just showing you something that you don't need to do. 2 times 3 a raised to 3. Okay, don't do this one. Okay, you remember that we are only multiplying the exponent to the other exponent. We are not allowed to multiply the exponent to the coefficient. Okay, that's wrong. Okay, so this one is wrong. How do we simplify this? 2a raised to 3. You write the exponent first of 2 and a. The exponent of 2 is 1. The exponent of a is 1. And then you distribute the exponent to the other two exponents. So you will have 2 raised to 3, then a raised to 3. It's just like 3 times 1, then 3 times 1. Of course, we can further simplify this as 2 raised to 3 is 2 times 2 times 2. We have 3 factors of 2, which is 8a cubed. Okay, so again, this one, do not ever try to do this one because this one is wrong. All right, next rule, quotient of powers. Okay, subtract exponents. So when we are dividing, okay, we are subtracting exponents. In general, if I have, let's say, a raised to n divided by a raised to m, should be same base, okay, same base only. Then you can just subtract n minus m. Okay, so that will be our general rule. Note, should be same base. If I have a squared and b 4, then we cannot subtract exponents here because they don't have the same base. So just leave it as is. This will be the answer, a squared over b4. And finally, oh, we have one more. We have 2 more. Okay, base to a negative power. Any conjecture here? What about this? Move it and lose it. In general, if we have a base, for example, raised to a negative exponent, remember that we only have 2 parts in our fraction. I have the numerator and denominator. Okay, so this one is in our numerator. So just move this one. It will go to your denominator. Okay, that's why we're moving it. Move this, the entire thing, but then you have to lose the negative sign. Okay, of course we can't complete this without the numerator, so you always have to put 1 as your numerator. Okay, now if, let's say, you have your negative exponents in your denominator, still you have to move and lose it. Remember that this is in your denominator. Then when you move it, it will go where? It will go to your numerator, and then we have to lose the negative. And then this over 1, we can just write this as b raised to n. All right, finally, last one. So anything raised to 0 is equal to 1, provided that your x is not equal to 0. Okay, note that we can't apply 0 raised to 0. Okay, we do not have a value for this. This is undefined. We don't have 0 raised to 0. So anything, well, except 0, if you raise it to 0, it will be equal to 1. So just be careful. We can't have a base equal to 0 when you're raising the base to 0. Okay? Okay, let's do the warm-up. Anything raised to 0 is equal to 1. Just be careful which expression is raised to 0. Now, which expression here is raised to 0? Y only. So then you will write this 6. Then y raised to 0 is 1. Okay. Now, the entire thing here was raised to 0. So 8y, quantity raised to 0, is just equal to 1. Okay. And then, now before we answer negative 5 raised to 0, let's try to discuss the difference between negative 5 raised to 0 and the quantity negative 5 raised to 0. Here, the negative 5, including the negative sign, was raised to 0. Here, negative, then 5 raised to 0. It's only the 5 that is raised to 0 here. We have a coefficient here, which is a negative 1 times 5 raised to 0. So when you rewrite this, you will have a negative 1 times 5 raised to 0. Now 5 raised to 0 is equal to 1, but you still have a coefficient of negative 1 here. So negative 1 times 1 will give you a negative 1. So this is actually equal to a negative 1. This one, the entire expression, including the negative sign, was raised to 0. So this will be equal to 1. So that's the difference between negative 5 raised to 0 and then quantity negative 5 raised to 0. Using this concept, negative 5 raised to 0 is equal to negative 1. So 6 times 1 is 6 plus 1 minus 1. Use your PEMDAS, you'll get 6 as your final answer. Okay? All right, now number 2, we are multiplying a monomial with another monomial. As what we said last time, you always start with your coefficients. Coefficients, just multiply them like regular numbers. Okay? The rule that we learned ever since when we learn how to multiply, just apply that procedure. So here, what's my coefficient here? Negative 1. So you will do negative 8 times negative 1. And then your a squared times your a4. And then your b times your b cubed. Now, what's negative 8 times negative 1? Positive 8. Now, we have the same base here. Okay, so what should we do again? If we multiply a monomial with the same base, keep the base, a, and then add the exponents. 2 plus 4 will give us 6. Right here, note that the b here has no exponent. So we have to write the exponent first, and that's equal to 1. Same thing. We are multiplying b raised to 1 and b raised to 3. Keep the base and add the exponents. So it will be equal to 4. Can we multiply a6 and b4? Okay, because they are not the same base. So we just have we will have a6, and b raised to 4. So this will be your final answer. Okay, we still have time. What if we have 2 raised to 2 and then 2 raised to 3? How do we simplify this? Go ahead, Maya. Maya? Since we have the same base, keep the base, then add the exponents, which is equal to 5. Okay? Of course, we can further simplify this. 2 raised to 5 is 2 times 2 times 2 times 2, 5 times. It will be equal to 32. Okay? What if I have 2 squared times 3 raised to 3, for example? Can I just add the exponents? No, because we don't have the same base. So how do we simplify this? 2 squared is 4. 3 raised to 3 is? No. 27. Then just multiply the 2, and that will be the simplified answer for this.